So we have some guests here, so welcome. This is a course for Management Consulting Practicum. So the students are actually team in different groups, and then they have been working with Greg for the entire semester, trying to identify his business needs and trying to act as a consultants for Greg. And so today is our final class, and they are going to give a final presentations, but in between they have given some presentations to Greg already. So today we have 4 teams, and we will start with biofuels team first, and then each team will have 10 to 12 minutes and to give a presentation, and you will identify some recommendations that you wanted to make to Greg. So let's start with biofuels first.
Okay, hello everyone. We are the Biofuels group, and today we just wanted to share with you our final recommendation for Avari Labs after all of the research we've done this semester. Just a little quick insight. We are the Biofuels group because that's what we originally started researching, so a lot of our earlier research targets towards that industry, but we have some final recommendations that are all encompassing. Just kind of wanted to review what we've talked about with Greg this semester and look forward to sharing with you guys what we've found and what we've decided as our final recommendations. So I'm Katie, I'm a senior in marketing.
Hi, I'm Nicole. I'm a junior in economics and political science.
I'm Nico Panoa, a junior studying finance and accounting.
I'm studying in econometrics and quantitative economics, and I'm in a senior year.
I'm Melly, I'm a freshman, and I'm studying integrated business and engineering.
I am Will, and I'm a senior studying management and finance.
So today we're going to cover the biofuels industry, dewatering and drying, the pilot test facility, financials, and our final recommendations. First, with the biofuels industry, just wanted to recap some of the research we've done. The pros to the biofuels market is that it's been predicted to grow at a compound annual growth rate of 8.3%. The market obviously has profitability potential, which you can see on the right-hand side here, and the global demand is set to grow by 41 billion liters. The cons of this industry is that it has a high cost of production, especially for Greg's cause. They produce a lot of pollution, which can be concerning for the EPA and can cause issues with gaining grants. And it often has a lower yield in comparison to other fuel sources. And you often need an intermediary product to create biofuels such as algal oil, which we'll talk about a little bit later.
Yeah, so like Katie mentioned, as we were researching the biofuels industry, we kind of stumbled across the algal oils market just because algal oil is an intermediary product of along the lines of like microalgae to algal oil to biofuel. So that was a potential market we thought Greg could break into. But the problems with this market is just there's a very high upfront production cost to enter the market. To make algal oils, you either need an open pond system or photobioreactors. And when we looked at the numbers for that, it just didn't really make sense, like the cost per liter of product versus the cost of just getting that technology up front. However, the market is predicted to expand at a pretty good compound annual growth rate. So the market is good. It's just really high upfront costs.
So now we're going to cover a quick SWOT analysis. Strengths of the biofuels industry include that it's a renewable source of energy. It can boost local economies. The opportunities include that they reduce reliance on crude oils, and there's a possibility to create new green jobs, and that global consumption is steadily increasing. The weaknesses and threats for the biofuels industry are kind of why we came to the conclusion we've decided on. The weaknesses include that there's a need for highly qualified workers, which obviously can be expensive. And there's a high cost of conversion tech. And as Greg knows, it's obviously a lot of these processes used in the biofuels industry are very expensive upfront costs. And there's also consumer wariness. Everyone typically tends just to use what they're comfortable with, and biofuels isn't something that consumers are leaning towards at the moment. But that could change in the future. And then that you need to produce large quantities, which of course, again, is another issue that Greg would potentially face as it's kind of starting out in a pilot facility, that might not be the best idea. And then the threats are that there's a very high volume of competition, and there's a lot of negative environmental impacts, which I touched on earlier. And like I mentioned earlier, there's also uncertainty with government policy, and it could change at any moment. So our bottom line for the biofuels industry is that we don't recommend that you pursue the biofuels market. A lot of the other groups seem to have a lot more promising research for their markets. So that's kind of what we have recommended for you in terms of the biofuels market.
Yeah, so then we also worked on focusing on two parts of Greg's process and finding out the best ways to start those. So the first is dewatering. There's two main processes that work the best. The first is filtration, which is slower than the normal centrifugation process, but is a lot simpler, and it has a lower cost than any other alternative when it's done right. Flotation is the second type of dewatering, where the cells are trapped on micro air bubbles and float to the surface. They're using it in the mineral industry right now, but it needs more testing and research before we can start using it to microalgae. But beginning studies have shown that it can be more effective, and it's the most economically sound process for doing stuff like this in bulk. Moving on to the drying, there's three different types of drying. The first, that's the most common, is the cold air drying, where you just use hot or cold air to dry the microalgae, but it has a lot of variability with the air that you're using. Then there's hybrid solar or air drying, which uses air heated by the sun that's circulated by fans to reduce cost. And you can usually control this with an algorithm that looks at the temperature and the humidity in the room. The third newest one is using isopropyl alcohol, which has a lower surface tension than water, to create a gradient and use it to separate algal material. It is 95% efficient, and it works at room temperature, but it needs more research to see if you can use it on all different types of microalgae.
So I'm going to talk about pilot facility. Our purpose was to design and build a pilot facility at Avari Labs, and our objectives included selecting a pilot facility design builder. Next slide. Based on the key criteria such as cost, experience, customization, and technology, we also compared chemical engineering and civil engineering approaches. And met with Process Engineering LLC to develop a design basis, process flow diagram, mass and energy balances, and a major equipment list. And we evaluate several pilots of facility builders. And finally, we found that Process Engineering Associate LLC was the most suitable for Avari Labs. Can you go with next 2 pages? We had extensive experience in designing and building pilot plants in the chemical engineering industry, and the project required approximately 130 hours. We were able to achieve a successful pilot facility design that met the specific requirement of Avari Labs. So we recommend Process Engineering Associate as a pilot facility builder for Avari Labs perfectly. And if you go to the next page, I did a little bit more research about this. I'd like to discuss the potential of microalgae-based treatment for textile industry wastewater. The textile industry is known to produce large amount of wastewater, which can contain harmful pollutants that can be detrimental to the environment and human health. This process involves several stages, including pre-treatment, microalgae cultivation, harvesting, and processing and post-treatment. And one of the main advantage of microalgae-based treatment is its availability to remove a wide range of pollutants from textile industry wastewater, and it can also generate biomass or biofuels. Can you go 2 slides after? So overall, we believe that microalgae-based treatment has significant potential as a sustainable and cost-effective solution for treating textile industry wastewater.
All right, so for the pilot facility construction, I kind of got some estimations from my father, who has been 30 years in the construction industry, building commercial buildings and other things like that. So he kind of gave me a good estimate. So for a new building, it would be around $150 to $200 per square foot for the building. Overall cost being between 1.95 and 2.6 million USD, based on 13,000 square feet. Uh, Also, if you look at 580 Tracy Road, which is a property we showed you earlier, it's about $50 per square feet, just for the building, which is already built. So renovating that would be about 75, or renovating any other building would be 75 to 100 per square feet, which translates into 975,000 to $1.3 million. Industrial space would be about 25 to 35 square foot, and then right over here, you can see for 580 Tracy Road, I took the total assessment of the building, divided it by their total square footage to get around 50 per square foot. Labor costs, assuming a staff of 20 to 30 people, would be around 1 to 2 million a year, for engineers and other people like that, highly specialized people. Utilities, including electric and water. I'm not completely sure about the wattage per week, and water gallons per week or liters per week, but I estimated around 335,000 to 660,000 USD a year, assuming average electricity cost of 17 cents per kilowatt and energy consumption of around 3.38 kilowatt per metric ton of microalgae produced. The weekly cost of electricity for producing 1 metric ton would be around 574.60 a week. And yeah, I wasn't sure about the amount of water exactly per metric ton, but I estimated 500 to 1,000 gallons. Now, assuming a cylindrical design, the photobioreactor would have about 5.7 meters, which equates to 10.7 square feet. And several hundred to even 1,000 square feet could be taken up by these photobioreactors, depending on how many you have. Centrifuges require a space of 500 to 1,000 square feet, and then sensors and monitors, depending on their level of automation and type, are 200 to 500 square feet or more. Next.
And now we will talk about financials, and I want to talk about the growth rate assumptions between the funding rounds. So for the startup to first angel, we assumed a growth rate of 7%. And this is because it's still on Greg, so growth will be slower than with investors and additional capital, but it is still beating inflation and growing. The first to second angel, assuming a growth rate of 10%, since Aquaspark has made similar investments before, they can increase growth through knowledge of the industry. And then second angel to first venture capitalist, 12% growth rate. Second angel will have capital and also a network which Avari could utilize. And going on to first venture capitalist to second venture capitalist, growth rate of 15%. Venture capitalists have done this to many companies before, so they know what they're doing, and they'll find ways to improve efficiencies within the process, which will increase the growth. And now going on to the cap table, here we have 4 rounds. The total funding is 90 million with a post-money valuation of 103 million. So we see that we came to the recommendation that 3 million from Aquaspark is a good investment, given that you will remodel for your pilot facility, as building from the ground up will have to take a little bit more capital. And we see after the second venture capitalist round, a share price of $10.98, which is a good increase from the 30 cents per share from the first angel round. And now we'll talk about the return on exit. So given these different exit valuations, you can see that all the returns that investors will receive, and we maintain Greg to have 47%. So he's taking away majority of the value of the company, but you see that there'll be a good return for the other investors as well.
Okay, so now I'm going to talk about packaging for a quick second. So as you can see from here, 200-liter drums are the biggest container for microalgae, and while they're the most expensive, they hold the most microalgae. So you'd want to use drums to minimize labeling costs, which are 5 cents to 10 cents per package. It's my recommendation.
Okay, so now that we've kind of talked about the more specifics, we're just going to discuss like some general recommendations that we have for Greg and Avari Labs. First of all, research-wise, there's different avenues he could pursue just based on calls we've had with him and our research we've done. There's a possible process where he adds yeast into the process instead of trying to take it out. It could add nutrients and eliminate the need for contamination prevention. But that would only be applicable if he's going into like the aquaculture industry. And then he could also pursue a modified vortex filter system. So if he wanted to pilot that, that could enhance his filtration systems, both on a smaller scale and in the pilot test facility. And just in general, we think, and Greg knows that he needs to bring in more business partners. So that's going to look like labor for the facility, financial and business experts, so they can run that side of it more while he's in the lab, and just like companies interested in partnering in general with Greg. So overall, just a couple of recommendations to wrap it up. We definitely think Greg should focus in on one industry just so he can really start to specialize in that. Like we said, we don't see biofuels being that industry, but we trust that the rest of the groups are going to kind of give him better recommendations from that. Aquaculture seems to be where he has the most current expertise, so that could be an avenue to explore. We think he needs to purchase or build a pilot test facility. We ran through some of the financials for that, so whatever makes the most sense for you, I think, but there are several facilities for sale in and around Indiana, and there's a lot of land around here too if you wanted to buy it. And with that, we think that you need to scale up operations. We recommend hiring engineers or maybe a consulting firm to kind of assist with that, just so you have a little bit more expertise in that. And then obviously bring in some investors just to show how profitable the initial facility can be. And then from there, you'll get even more investors, ideally. So that kind of concludes the biofuels group's presentation. So please let us know if you have any questions, and we wish Avari Labs luck after the semester.